Okay, we're going to go over derivatives of product and quotient rules. So here we have a product function, which is essentially we have two values that need to be multiplied by each other. And for our derivative of two products, or a function that deals with almost like two functions within themselves, the derivative is simply taking the derivative of the first function, multiplying by the original of the second, and adding it to the original of the first times the derivative of the second. That makes sense? Okay, so we'll go through this concept quickly. We'll keep that up there. So if that's the case, this is what we'll call our f at x, and this is what we'll call our g at x. Okay, so, and our h at x is technically this. I guess I should use a different letter. We'll call this h at x, just to be more consistent. Okay, so if this is our h at x, okay, we have to find a derivative of the first function. So we actually look inside of the brackets, and we want to find f prime x, okay. So in order to do that, we got to use our power rule. If we're deriving this, do you know what we do?
It's 2x. Yeah, just 2x.
Just 2x. The 2 comes down, this becomes the power of 1, and because this is a constant, it's essentially 0. So, with that idea being said, that means our f prime x is just 2x, and we multiply it by the original g at x, right, which is x squared plus 1. And then we added to the original f at x, and the original f at x is x squared minus 3. And then we multiply it by g prime x, so the derivative of the second one, which in this case is, again, just 2x. We then take our distributive property, right, and we do it for both of these functions. So this becomes 2x cubed plus 2x, right? That's the derivative. And for other one, we get added to 2x cubed minus 6x. Does that make sense? And we collect like terms, and our new function ends up being 4x cubed minus 4x. That's not a cubed, I didn't write that in. Cube minus 4x. And we could simplify something like this, but this would be our standard form. We could technically pull out 4x out of everything, and we'd be left with x squared minus 1, and then this is the difference of squares. So we can go into a whole bunch of factoring, right? But this is essentially what our goal was, to get to this end. Now, with that being said, this same idea, I'm going to show us a different function here. We'll call it a at x, which is usually rare. We usually don't say something like that, but that's fine. And what I'm going to do is I'm going to take our original f at x, and I'm just going to divide it by g at x. So we have x squared minus 3, but this time it's going to be divided by what was it? X squared minus 1, right?
Plus 1.
Oh, was it plus 1? Oh, yeah, you're right. Good. Okay, so in this case, this is like our f at x divided by our g at x. But we haven't learned quotient rule, let's say. And maybe we have or haven't. I don't think you get to it for a bit. But we can actually make this a product rule, because if we think about this, these are two numbers that are technically multiplied together. And what I'm going to do is I'm going to split it so we can see that concept. In the first one, it's like x squared minus 3 over 1, right? And multiplied by 1 over x squared plus 1. Okay. Now this over 1 we know eliminates. We can divide anything we want and it stays the same. But let's say I don't want to work with a fraction. Okay. How can I change this value so that it's no longer a fraction and becomes a number above 1? Do you know what we can play with here?
Multiply by x squared plus 1.
You're right. We could do some kind of rationalization, but there's actually a much simpler step. One of the things we do is we can play with the exponent. If this is the exponent of power of 1, do you remember what we can do with an exponent like that to flip the fraction?
To power of negative 1?
Yeah, exactly. So then we end up with x squared minus 3, and we'll just put it in blue here, x squared plus 1 to the power of negative 1. Okay. Now, we'll have to know a little bit of our chain rule for this, and we'll get into the chain rule in a second. But essentially what this does is it makes this a product function. Okay. And what we're going to do here is think of this like this is our f at x, just like we said it was before, and this is our g at x. Okay. Well, if this is the case, and remember we called this our a at x, if we want to find a prime x, okay, we know we'll have to find the derivative of the first one, which f prime x we already know is 2x. And we keep the original of the second, so x squared plus 1. The only thing that changes here is when we find g prime x, because we have a chain rule here. So originally we keep the original f at x, or minus 3. Does this make sense?
Mm-hmm.
Now this kind of becomes a chain rule. We have to bring down that negative 1. So because it's a chain function, when we bring that negative 1 down, we're multiplying by negative 1. The bracket still says as x squared plus 1. And then what will the exponent be here?
Negative 2.
That's right, it'll be negative 2. Now with a chain rule, technically we still have to derive inside that function also. That's what the last part is. And when we derive inside that function, we get 2x. Okay? So but what we've done is we've changed the quotient question into essentially a product. And from here we can simplify. Okay? We already know that this part here simplifies to 2x cubed plus 2x. Okay? And this part here, I'm going to try to simplify our terms here. We know that negative 1 times 2x. Okay, so I'm going to say plus, and we'll put a set of brackets around. That will be negative 2x. Okay, and I can multiply that by this bracket here, which I'll do next. Minus 3. This here, though, is kind of like a divided by, right? And I can bring it down right now if I want, or I can leave it how it is. I'm going to leave it how it is right now. X squared plus 1 to the negative 2. Okay. We can bring this in because there's a rule, an associative property. When you're multiplying, you can essentially multiply in any order, as long as you multiply everything. So we bring in our distributive property here. Okay, this stuff all stays the same, 2x cubed plus 2x, okay, and then plus our bracket. We bring in this negative 2x, we get negative 2x cubed plus 6x, okay, and still needs to be multiplied by what we have here. Now, the best way to really go about this is because we have to keep that exponent, would be to turn this into a fraction again. Okay, but essentially, if we were to do the tangent, it's usually as nice as to simplify. I'm going to turn it into a fraction and incorporate the rest of it. So we have 2x cubed plus 2x, and then because this becomes on top, it's like minus 2x cubed plus 6x, all above. Ooh, that's an ugly one. Let's use a line here. All above x squared plus 1 squared. Okay. And we can get like denominators and put everything together if we like, but technically this is the derivative. There's nothing wrong here. It's just kind of ugly to look at. Okay, and there's a lot more we can do with simplifying, but the whole idea here is we can technically turn any quotient function like we had here into really a product and chain rule by just making it into a product instead. Does that make sense?
Yeah.
Yeah. Okay, good.